Hello and welcome to this week's problems. We're all about angles this week. So we've got question 1, we've got angles on a straight line. It says not to scale, and that's important because it means we can't measure it using a protractor or an angle measure of any kind. So, not to scale. We've got a straight line, we've got an angle here, which is 65 degrees. We've got this angle here, which although it doesn't say what the angle is, because we've got a square there, that means it's got a right angle. This is 90 degrees here, and then we've got a missing angle is y. Now we should know that angles on a straight line are 180 degrees. So if I was facing this way and I turned all the way around to face the other way, I would have turned through 180 degrees. Think about your skateboarding tricks. So the full line is 180 degrees, and that's made up of 3 parts. We've got 65 degrees on the end, we've got 90 degrees in the middle, and we've got y, which we don't know what it is yet. And because we've done these sorts of problems before, we know that if we have 180 on the top and we add together these two numbers here, so we add 65 and 90, that gives us 155. So these two are worth 155. If we take that away from 180, it will tell us how much y is. So if we imagine we take that away, take 155 away from 180, it will leave us with the value of y. And once we've got our answer, it's easy to check because the 3 numbers that we've got should add up to 180 degrees again. So 180 take away 155. So we've got 0 take away 5 we can't do. We need to borrow from the column. 10 take away 5 is 5. 7 take away 5 is 2. 1 take away 1 is 0. So we're left with 25 degrees. Don't forget the degree sign, that's important. Here we've got another problem. It's very, very similar. We've got PQ is a straight line. P and Q just refer to the 2 letters on the either end of it. It says not drawn accurately up here instead of not to scale, but it means the same thing. Calculate, again, so calculate, not measure, it's the important word there, the size of angle X, which is the one in the middle. Do not use a protractor angle measurer. So it's exactly the same thing. So you should be able to have a go now, hopefully, at using the diagram in the same way. We know that a straight line is 180 degrees, so our total is 180 degrees. We've got 3 parts to our 180 degrees. We've got this part over here, this part here, and this part here. The difference between this problem and the last problem is that the 2 parts that we know, which are here and here, aren't next to each other in the angle. But it doesn't matter because all 3 parts still add up to 180 degrees no matter how we'd put them together. You might want to pause the video now and see if you can complete the bar model and the calculation and calculate the size of angle X before I give you the answer. Right, well, welcome back, or maybe you never went away. I'm going to go through now to get to the answer. We have got 47 as one of the parts of our straight line. We've also got 26, and we've got X on the end, which we don't know what it is yet. So just like before, I'm going to add together the 2 numbers that I have got. 47 add 26 will give me, well, 7 add 6 is 13, so now 6 add 6 is 12. Carry the 10 across. Got 4 add 1 is 5. 6, 7 gives me 73. So these 2 angles together make 73. If I took 73 away from 180, it leaves me with the X on the end. So I'm going to do that. 180. Take away 73, making sure I'm lining my digits up okay. 0 take away 3, I'm going to have to borrow from the tens column. 10 take away 3, then is 7. 7 take away 7 is 0. 1 take away 0 is 1. Which leaves me with the answer 107. And you'll see that I haven't drawn my bar model accurately because my 107 box is smaller than my 73 box, but not to worry. And now because I've got my answer, I think whether it's reasonable, and I can also check because I know that if this angle here is 107 and I add it to 47 and 26, and I should get 180. So 7 add 7 is 14, add on the 6 gives me 20. Okay. 20 add 40 is 60, 70, 80, 180 degrees. I can be confident now that my answer is correct, 180 degrees. Right, so we've got another one this time. We have got a triangle. Again, it says not to scale. And we cannot use a protractor or an angle measurer because it's not to scale. This isn't 35 degrees. This probably is 90 degrees. So we've got the triangle up in the corner here, so we know, not the triangle. The square up in the corner of the triangle, which means that is 90 degrees. We've got 35 degrees down here. We've got a missing angle Y. We've got to work out the angle X and angle Y. We'll start with angle Y because that is like we've just been doing. We've got angles on a straight line. We know they add up to 180. So you might want to pause now and see if you can work out angle Y. Welcome back. Hopefully you've got an answer. If not, I'll show you. So we've got two parts to this line here. We've got 35 degrees and we've got our missing part Y. So we just simply do 180, take away 35, which gives us 7 take away 3 is 4, 1 take away 0, 145 degrees. I can check that by adding 145 degrees back to 35 and it should get 180. So 5 add 5 is 10, 4 add 1 is 5, 6, 7, 8, 180. Angle Y is 145. Now the next one to do is the triangle angle X here. Now you may not know, but you do now, that all the angles in a triangle total 180 degrees. So this is just like the problem we had before where we had two missing numbers. Because of that square up there, we know that's a right angle. So you might want to pause now and think about how you might do this with our three parts. Right, so now I'll have a go at a solution. 180 degrees. Got 90 degrees here. I'm going to put 35 degrees in this box. Just like before, we need to add those two together. That will give us 125. Take that away from my 180. 180, take away 125 will give us 100. It won't give us 155, it will give us 55. I can check that by adding these two numbers together. That should give me my total 180 again. So the important thing to remember is angles on a straight line, angles in a triangle, all add up to 180 degrees.